Hi, I'm Eric Rangell, and my idea for Hackfest was to adapt a karaoke to the Apple I. I have no idea why I would want to do that, but I wanted to do it. Okay, one of my ideas was to adapt these Annunciator 2 MIDI tests. A problem I had with the enhanced Apple IIe was that the Annunciator 2 did not play the music. I had to switch it to Annunciator 0. Yeah, the reason for that is there's certain signals, there's a capacitor that can't get the fast on-off rate on Annunciators 2 and 3. So just for a quick overview of what this system can do, some tests of the MIDI out. Okay, played a chord, and that was by bit banging the Annunciator 0, and that's the code that does it. And then on this Yamaha guitar, it has these lights on the frets. So here's a program that turns the lights on and then turns the lights off, because those are system exclusive MIDI messages that the guitar recognizes. Okay, so my crazy Hackfest idea is, what if we could do karaoke on the Apple I? So I created a test song that I wanted to see if I could send through the Apple I keyboard input. You can see the karaoke at the bottom. Just starting it very simple. That's Band in a Box that was used for the arrangement. Okay, so it would print some text. Okay, so the / is end of a line, / is end of a paragraph. Now we're sending lowercase. The ampersand. All the other characters. So that's the test case, and I wanted to print it nicely on the Apple I following the lines and paragraph marks. Okay, so now we're going backwards to an unenhanced 2E. So the MIDI is the same circuit. It's only 3 wires. You really don't need buffers. So you just have a resistor between power and pin 5, and then ground is pin 3, and then pin 4 you could directly connect to Annunciator 2, because this software, I decided to use Annunciator 2 because I'm using 1 and 0 for this Arduino SPI interface to an SD card reader. Okay, so I want to just show you one program I added to this disk. It's a drum player, so then you could just press ASCII. So if you want your kids to drive you crazy, you let them play with this. Hit escape to stop it. So that's just MIDI out on MIDI channel 10 for drums. Okay, so now we're going to see some weird artifacts of an unenhanced 2E's 80 column mode. So I'm going to play the same song and watch where the lyrics go. It's like using 40 columns. Watch where this goes. Okay, I think there's a way in code to handle this. I just haven't had the chance to look at it. Now, the other tool I wanted to use in my Hackfest project is this SD card interface, and this is how it is hooked up to the gain socket. So it's doing SPI, and I can't tell you what the S's mean anymore. But here is a demo of it. If I type +FATCAT, going to read the SD card and tell me what is on the SD card. Okay, so it just read the root directory and found these. So what I was hoping to be able to do is this. Fat cat, oops. So if I wanted to always go to the A1 karaoke directory, A1 Kara, and then I'd have directories like 001. And then in there, I was hoping that I'd be able to figure out how to read a file into memory from that. Now he has a fatget command, which will take a file name in this format with the ciderpress type and starting address appended, and it will load it into, it'll copy it to the floppy disk. So I could try it with another file. So, okay, so I tried going into the assembly code and the plasma code to see how I could do this, and yeah, it makes sense when you read the code, but actually getting it to work the way you want to is a challenge. Okay, so this is the Apple I Replica. It's a Replica 1 Plus, and I'm going to hit reset, so that gives me the ability to type, and clears the screen. Okay, so I wanted to be able to type in something from an Arduino, which I've already built. I just have to plug in that Arduino. Okay, so on the LCD, I can select a file, and then it starts typing it in. It's a text file, and it's typing it into the Apple I via the keyboard socket. So this proves it can be done if the power is right. Now, there's some glitches it looks like I'm getting, but I don't know. Let's try it out. 2, 8. Okay, so now I'm going to disconnect it. Okay, so it loaded my code into memory, and I disconnected the loader Arduino, and now I'm going to run the code. So this is my first version of my Apple II karaoke. So I figured it would show the like 8 lines of the song up here, like it would read forward from whatever is inputting it into the Apple I, and then down here it would show 1 line at a time, and then it would repeat. Okay, so like this would not exist first. Like it would just print up to here, and then it would print the line you have to sing, and then the words with a little symbol underneath, like a bouncing ball. And there is a special character in the Replica 1 that I can use for that. These are the 4 extra graphics characters that come on the Replica 1 Plus. So there's the left pointing arrow, there's an A with an umlaut, there's that up left pointing arrow, and the vertical bar. So I wanted to use these in my splash screen. Okay, but this code right now, it just takes and echoes whatever I type in back. So I can hook up something to the socket and see if the characters are coming through. Now, originally, I had the idea of having the Replica 1 communicate out and maybe try to play the MIDI itself using an extension to these sockets and using the address bus, but I found that I was using an Arduino to read it, and unless I got the timing right exactly, I wouldn't get the data properly. The first step in this Hackfest project is getting the Apple I to light up some LEDs. So I'm using a board extender, and I'm using the address bus. So I'm using 6 bits of the address bus to do communication with the Apple II, and I'm doing this by using the B000 page range, so that when the high bit of the address bus is B0, those rightmost 2 LEDs will turn off. So this is an example of how to turn off the rightmost 2 LEDs by addressing address B000 repeatedly. So it loads that address and then jumps back in a loop. So when it's in that tight loop, the address bus stays at B000. And then the other bits I can do with B4, B8, and BC. So I'm going to run this program. Okay, it's running, and you see that the rightmost two LEDs are off, and the address bus has 1011, which is a B. Okay, so I just changed the program to use B4, and I'm running it, and now we see the rightmost LED is on, so that's a 01. Okay, now we're going to change it to a B8 and run it, and this should give us a 10. Yes, the left green LED is on. Okay, now we're changing it to a BC, and we're going to run the program. And now you have both LEDs on. So we could send 2 bits out into an Arduino. The Arduino can check for the B in the address bus, and the next 2 bits would be data. And it could use like an alternating protocol where one of them goes on and off and the other one represents the data. So I'd become aware of my reality distortion field, so before I reattempt doing anything with the Replica 1 hardware, I got to get my logic gate circuits working correctly. So a lot of the fun of this was trying to get a good development environment going for the Replica 1. And I started using OpenEmulator. Now this actually has a CFFA that you could use, and I tried playing with that. The thing is, how do you get it off of that? So, like, if I enter code, here I'm using the Crusader assembler, and that's something new I had to learn. I hadn't used it before. So, like here, if I list my code in Crusader, also there's no easy way to stop it. The manual says you're able to stop it, but I can't find a way to make that work. All right, so I added a routine just to show you where I am right now in this project. So if I go to the monitor and I do a 280R, I was working on the splash screen. And why isn't that working? Okay, this is why it's not working, because I made the 280 jump to a return, and there was nothing to do there. But the real code that I want to run is, where is it? Yeah, okay, here it is, A90D. Yeah, see this 30, that's the end of the text for the splash screen. So here's the code that I want to run. So that is 60FED, so 60DR. And that's the start of my splash screen. Now I want to use special characters on the Replica 1, and they're not showing up on the character set in OpenEmulator. And I actually tried it on the Palm one as well. Okay, so to design the spreadsheet, to design the splash screen, I made a spreadsheet for 40 columns by 23 lines. So what I wanted it to do was, I want that vertical bar from the Replica 1 to be used, and then that middle is the tilde character, which will be a triangle character on the Replica 1, and then there's an umlaut as the point of the exclamation mark, and that is the left curly brace character. And there's one more character. Oh yeah, for the bouncing ball, there's a character that looks like an up arrow squirrely, and that's what I would use as the lyrics are shown. Yeah, so here is showing how it would, like at each syllable, so like Eric, there would be the E is the first syllable, and then the second would go up to the space, and then the music, there would be one syllable there, mu, and then sick, by, melody. This Melody was going to write a song for this. And yeah, it would have a load song function, and then I used formulas to figure out how to break it into 4 sections, because you could only have up to 13 character strings in Crusader. So I did that, but then I got all the strings that I wanted to define out of that. So when I scroll down, you could see the assembler code. But in Crusader, you can't have strings with spaces in them, so I actually had to replace that with periods, and it just got messy. But I had a good intention. Okay, now what I really wanted to be able to show was to get it to run on this Apple II Plus, which has been converted into an Apple II with this ROM card, with integer ROMs. So, and a little keyboard adapter from Reactive Micro, if you lose your keyboard. Okay, so what I want, I hooked up game sockets, and I wanted to get that MIDI program running in 48K, and I wanted, like it to boot into the integer ROM, and I wanted to use that Plasma SD card reader, adapting the program to squeeze it in and make it work. So what I really wanted to do was read from the SD card into that Arduino, into the SPI protocol, into this game socket, and then send then also be able to use SPI to send commands to the Arduino to send the MIDI to the Apple I, and also to play the MIDI using that Annunciator 2 MIDI. That just became too ambitious. And then I did some tests on this Apple II Plus as well, with which has a language card. So yeah, I was asking in the hardware forum about, well, in the programming forum about ProDOS in 48K. So it turns out that ProDOS less than or equal to 1.1.1 will boot, but basic system won't load. So you'd have to write system files to boot your system. So I thought about that. I just couldn't find the time to dig into it enough. Okay, so after abandoning the 2 and the 2 Plus, I said, okay, I have this Apple IIc Plus, and I built a way of sending MIDI through it. And what I wanted, it sends at 19,200 baud. And what I wanted to see is, can I test sending karaoke lyrics as well? So this is just a program that plays C major scale. Okay, so this is the test program where I wanted to try to send karaoke to the Apple I, which required modifying the Arduino code to send it out pins, extra pins that go into the Apple I keyboard socket. So I added an ASCII out program, and its address is after the A2C MIDI program. And then in line 45, that's when I was going to send the character data and call the routine. And so line 100 is the data for the notes, and I wanted to send it as each note played. If I could send a character of what the note is, then that's a proof of concept for the karaoke. Okay, so this is the code that initializes the serial port to 19,200 baud and sends test MIDI note on messages or note off messages. And then that routine at 601A is what sends each byte of data out the serial port. Now at 6028, that's when I was going to test the karaoke lyrics. So I was going to use a meta event. So it's meta events in MIDI are in the MIDI file as FF is the code, but I would actually send the FF over MIDI, and then the 05 is the message type for lyrics, and then the 01 is 1 byte, and then I would poke in the letter that I want to send. So like 43 is the letter C in 6037. Okay, and then that would send those MIDI bytes out. So it turns out that the Arduino code, the phases, I just couldn't get exactly right. And I was also a bit ambitious. I wanted to have a Charlie-plexed display hooked up as well to this Arduino. So the 2C would essentially be playing the MIDI data using that what I showed you earlier, and but you would only look at the Apple I and the monitor to see the lyrics coming over as the song played. So then I could play the MIDI out here. So this Arduino has a lot to do. It has to get the serial data and determine, is it lyric mode or is it MIDI data, and keep sending that MIDI data through this. So there's a serial adapter, which is just a level setter that hooks on to the Arduino Mega. You need a Mega if you're doing this kind of coding because of the memory. And then, yeah, this is a socket to connect to the Apple I keyboard. Okay, so what I have here is a Raspberry Pi running the Palm One, which boots up, looks like an Apple I. How nice. You could do stuff. 300, you could see what data's in the memory. You could do ff00.fff and see all of Woz's code. There's amazing 256 bytes that makes this thing come alive. So what I was looking at was, so one thing I wanted to do was get Crusader running on this. Now, there are some nice commands that you could issue to, write in ROM and set your speed for data entry and use the full 64K. And I was looking at trying to figure out how I could replace the ROM, because right now F000, it has nothing. So what I needed was to load Crusader in ROM. So if I try to write to F000 right now, okay, but then I look at it again, okay, so it's allowing me to write to ROM now. And I think it's using all 64K. So what I had to do was copy the source code for Crusader, KRUSADER.text, and send it as ASCII and simulate keyboard input. So now it is typing in the source code for Crusader. Okay, we've typed in all of Crusader. Let's see what it does. Success on the Palm One. The files for this Hackfest project, go to github.com/erangell, and then the repository is kfest 2020, and the files are in this Hackfest directory.